Good evening. Have you ever wondered how to find the greatest common factor or least common factor in a number or an equation? Well, I'm going to show you how to find the greatest common factor using the prime factorization as my first method. Okay, so I'm going to go ahead and share my screen and we're going to go through it. Okay, share. Then we're going to listen. Okay. It's loading. Okay, greatest common divisors and least common multiples by Faith Brown. Okay, so greatest common divisors by intersection of sets. The GCF, as for short, of two natural numbers n and m is the greatest natural number k that is a factor of both n and m. We symbolize this as GCF n and m equals k. Okay, greatest common divisors by intersection of sets. Gary has 20 table tennis balls and 16 paddles. He wants to sell the common size packages containing both paddles and balls. What is the greatest common number of packages he can sell with no leftover balls or paddles? Okay, so we're going to work this. So you'll start by having 20 and 16 and you'll find the greatest common factor of both. So you'll start from 1. 1 times 20 equals 20. Okay, 2 times 10 equals 20. And 4 times 5 equals 20. So we know that those all work. So those will be the greatest common factors. Okay, so then we'll do, let me get a spotlight. Okay, there we go. Okay, so then we know that 1, 2, 4, 8, and 16. So then we'll do, okay, oops, 16, 16, 16. Okay, the greatest common divisor by intersection of sets. The set of numbers of 20 is 1, 2, 4, 5, 10, and 20. Sets of factors in 16 is 1, 2, 4, 8, and 16. And so we write the numbers out like this, 20 on this side, 16 on this side. And then, so the greatest of both of them, as we can see, are 1 and 1, 2 and 2, 4 and 4. And so which would be the greatest common of the both of those? 4. Okay, so let me erase these real fast. Whoops. Erase. Okay, and so then we know that the greatest common factor of both of those is 4. Okay. That's the least common multiples that Abby gave. So we'll find mine again. Okay. So now we're going to do greatest common divisors by prime factorization. As the number of factors becomes larger, it is not participable to list every factor and search for the GCF. Example, find the greatest common factor using prime factorization, 306 and 1176. Okay, so we'll start out using prime factorization of 308 and 1176. Okay, so we'll work 308. 308 goes into 154 2 times. Well, 154 can be split, so 77 goes into 154 2 times. Okay, 77 can be split. It goes into 11 7 times. Okay, so then we'll do the same thing for 1176. 1176 can be split to 588 twice. So then 588 can be split 294 by 2, and it keeps going down. And so you're left with 7, 11, and 77. So this one is 2, which we get right here. I'll show you. We get this by 2, 2, 7, and 11. So we're getting 2 to the second times 2 times 7 times 11. Okay, this one we're getting 2, 2, 2, 3, 7, and 11. So it's 2 to the square times 2 times 3 times 7 times 7. We'll make sure we're correct. Wasting all along. Okay. And there we go. Okay, so finding the greatest common factors by prime factorization. Next, we examine how the factors correspond. We expand the exponent notation and line up the factors that match, leaving any number of factors at the end of the factorization. So we get this, so we work it out just like we did. We see that 2 times 2 times 7 are the factors that are in both factorizations, as in right here, with the arrow shown. Okay, greatest common factorization by prime is we see that 2 times 2 times 2, or 2 times 2 times 7 are the factors that are in both factorizations. Therefore, the greatest common factor is 28. Okay, that's all I have to share with you today about greatest common factors. Thank you.